We're still doing exercises in section 1.3 of Stewart's Calculus, 7th edition early Transcendentals, and this one has to do more with transformations of graphs and graphs of functions, and we're doing number 3. So the graph of y is equal to f of x is given. Match each equation with its graph and give reasons for your choices. Alright, so let's see. A is y equals f of x minus 4. So that would be a horizontal translation to the right by 4. So if this is our original function in blue right here and it translates to the right 4, it's got to be 3. So I'll just do that right here. So A is graph 3. Alright, B. F of x plus 3. Well, that's just a vertical translation, up 3 units. And we can actually count this. So this point here moves up 1, 2, 3. And yes, that is most definitely the answer. So B is graph 1 right here. C, let me do C. Y is equal to 1/3 f of x. Okay, so when we multiply the outside of the function by the whole function, when we multiply the whole function by a number, we manipulate its vertical appearance. So if we multiply it by a whole number, it is a vertical stretch. If we multiply it by some sort of fraction, we get a vertical compression, and the only one that looks like a vertical compression of this thing is graph 4. Okay, notice the intercepts stay the same with vertical compressions and stretches, so that needs to stay there. This one moves, and it moves. It should move down. The whole thing should move down 1/3. This is the highest point, so it should go. So this is at 3, and 1/3 of 3 is 1, and here's 1, so that works. So yes, the graph of C is 4. Okay, this isn't too hard. D. Y is equal to negative f of x plus 4. Okay, so a negative, when you multiply the whole function by a negative, is a flip around the x-axis. Okay, so the flip is going to look, let me do this in a different color. The flip around the x-axis is going to look something like that. And then you're adding 4 to the argument, which means you're going to the left 4 units. So right here. So D is the graph of 5. And through the process of elimination, we could just say that E is the graph of 2. But I will tell you why. Okay. So let me do it in red this time. What we're doing to the function is we're multiplying it by 2. We're increasing its height essentially by 2. We're doubling it. So its height originally is at 3, and if we double it, we get up to 6, which, as we see, this is in fact 6. So that confirms the height issue. And then we're moving it, we're adding to the argument, so we're moving to the left 6 units. So 1, 2, 3, 4, 5, 6, and that works as well. So graph 2 is most definitely the graph of E, and this was a pretty simple problem. So stay tuned for harder ones.